Okay. So unfortunately, this screen does not appear to be working, so I'll be turning my head a lot. Um, so basically, a lot of the way the course is going to work is I'm going to essentially ask you guys to follow along. I know that I wasn't able to get instructions out to everyone before this class, but we're going to be operating in RStudio, and so feel free to go ahead and download that and follow along if you want, optional. A lot of the lecturers are going to present some of the tools and techniques, and then we immediately sort of follow with a tutorial so that you guys can actually see how to do it hands-on. So definitely encourage you guys, if you want to follow along, pull out your computers. All of the code as well as lecture notes will get posted to Canvas every day at the following the lecture. Okay, and another note is that if you are very comfortable with programming in general, I teach everything in R, but you don't have to do it in R. So if you're doing homeworks in like Python or something, that's totally fine. Just know that some of the packages and tools are going to be slightly different in different programming languages. So that's just something that you'd have to pick up on your own if you choose to use a different programming language. Okay? All right, so what you're seeing here, this is the user interface for RStudio. There's a couple different sort of pieces to look at here. Up in the top left, this is kind of your notepad. And then down here is the console where commands are sort of executed. And so I'll kind of show a little bit more hands-on in a second how that works. In the top right, generally it's kind of a visual storage of your environment. And so if you're storing variables and parameters and things like that, you'll be able to view them up there. And then down here, this is kind of a flexible area that does a couple of different things that we'll see as we go through some of the examples in class. Okay? So let me jump on over to the console down here. If I wanted to do some basic operations, I can do 1 plus 2. You can almost think of this like a sort of basic calculator to start with. 2 times 3, 3 to the 4th power. And I hit enter, and it will show me the answer, right, for each of these things. So as I execute these commands in the console and it spits back the answer, that's one way to sort of execute specific commands. As I'd mentioned, you can also keep them in your notepad so that that information can be stored. And so I'll say something like basic operations, and I can just have the operations that I just did up here. The pound or the hashtag symbol is a way to denote that everything in that line is a comment. And so all the text that follows won't be kind of like code. It'll just be essentially a note, right? And so I'm doing that to denote, below this basic operations. To pass a command from the notepad to the console to execute, you can press these icons over here. So this will run the current line or selection, and this one will rerun the sort of previous code region, and we'll get to that later. But mainly this button. So this will pass 1 plus 2, 2 times 3, 3 to the 4th. Then the keyboard shortcut, which you guys will get used to right? On a Mac, it's Command Enter, and on a Windows PC, it's Control Enter. Okay. Any questions so far? Yes.
Sorry, I was a little bit late. How do I access?
Yeah, so we are using a program called RStudio. Yes, you have to download that, yeah. So there's kind of two pieces to RStudio. So RStudio is like the interface, and then the actual programming language is R, so you have to actually download both of those in order to get this up and running. So, you know, fiddle around with it right now if you can. If it's too much of a hassle before the end of class, you can just not sort of follow along and just do it later. Yeah. Okay, so the next thing that we can do is we can, actually let me clear this really quick. Okay, we can store data as objects. Okay, so this caret dash, which is basically an arrow, is an assignment operator that basically says store store the value of 2 as x. Yeah.
Sorry, could we turn off dim the lights of the phone?
Yeah, sure.
Thank you.
Is this better?
Yeah.
All right. Yeah, feel free to interrupt at any time. Okay, so store data as objects. So I haven't executed this command yet. If I go down to the console and I just put x here and I hit enter, what do you guys think is going to happen? Nothing, yeah, invalid, right? So it basically says this object x is not found. It doesn't know what x is, right? We have to tell the program what x is first. And so if I go here and I execute this command, right, command enter or control enter, I will now sort of execute this. And if I go back down to the console and I hit x, what's it going to return? 2. Yes, great. Okay, and so the convention in R is to have an assignment operator as x arrow 2. Okay, and so those who are familiar with other programming languages, like Python, for example, you might ask, can we do something like this? X is equal to 2 as an assignment operator. So yes, actually this works technically, but it's actually considered not a good practice to do this kind of assignment operator in R. The reasoning is, or the reason for that is actually a little bit nuanced. There's like very sort of corner cases where it actually messes with some functionality. So basically I will say always do an arrow as opposed to an equals operator. Yep. Okay, and so we can do y is 3. Great. And so if I have x and I execute that, it enters 2. If I have y and I execute that, it'll return 3. And if I do x plus y, what will that return? 5. Yes?
I noticed that every time you execute, it says bracket 1, then
Yep.
what you want.
Yep.
Does that mean that indices in R start at 1?
Yes, that's right. So in most versions of like Python or other programming languages, depending on what programming language is, you're either starting at index 0 or index 1. So I'm going to talk a little bit more about this in detail a little bit later, but this essentially says your sort of index position. And so the first, if I'm returning like multiple numbers, the first position is 1, and you know if it's multiple rows, it'll tell you what the starting index value of the next row is. Okay? But yes, we start at 1 in R.
I know that MATLAB does that too, but I don't know of any others.
Yeah, I mean, there's a lot of programming languages out there.
Yeah.
So, okay. So x plus y returns 5. Yeah, 2 plus 3, right? Okay. We can also override the storage of data in objects. So you can actually see here, I was mentioning a little bit earlier, in the top right-hand side, the values that correspond to objects that you've stored. So x and y, which we've defined values for, are 2 and 3, and you can kind of visually see them up there. But I can change it so that x is 3, right? And so the value of x is now changed from 2 to 3. And if I do x plus y now, it will not return 5, it will return 6. So important concept, you can actually overwrite objects that have already been written. That can potentially lead to some dangerous things. If you are overwriting like native functions, or you're operating in what we call like an overlapping namespace. So if you're naming things the same thing, you might override something that you had defined before. So that's something to keep in mind. And so there are, good practices when you're doing programming to prevent you from, it's called polluting your namespace, to avoid issues like that. Okay, any questions so far? Pretty basic stuff, okay? So next up, so we're going to be talking about functions in a little bit. In more detail. Right now I'm introducing a very particular function called concatenate. Oh, sorry, I'm in caps lock. Accidentally hit that. Okay, so concatenate function. So this is a function that's denoted with C. So functions work by having an input and an output, right? And so you have some kind of input that goes into a function, and then that function will return an output. And the way that we use functions in R looks something like this. So you do the function name, then your input, and then this will return an output. And so the function name of concatenate is just C, and the inputs that I'm going to put into this function, let's say I'll do 1, 2, 3, 4. Okay. What do you guys think is going to happen here? Yes.
It has basically returns like a vector, I think. 1, 2, 3, 4.
Yeah, that's right. So hit enter. Okay. So now you'll see it's returning multiple values instead of one value. Starting again on index 1. We're going to talk about indices in a little bit. But now you can see that the output of the function is a vector that has multiple values. Okay? And we can do operations with vectors. So I'm going to define an object called x1 as C12. I'm going to define x2 as the output of this concatenate function, also 1, 2, and then we'll do x3, C123. Okay. So operations with vectors. X1 minus X2. What do you guys think it will return?
0, 0.
0, 0, right? So the way this works is, let me just hit enter first. Oh, I need to define these. I didn't actually execute these guys. All right, so now that those objects have been stored, which you can see over there in the area where, in the top right area where the variables are displayed. Okay, I execute line 27, and I get x1 minus x2, and the answer is 0, 0. So essentially what is happening is it's going to take the first entry of x1 and subtract the first entry of x2, and then that returns 0 for the first entry of the output. And then it's going to take the second entry of x1 and subtract from the second entry of x2, and it will also return a 0. Okay? Okay. So knowing that, don't run this yet. What do you guys think is going to happen?
Or error because the vector set of 0, 0, 0, 3.
Yeah.
I'm guessing it might be 00 NA.
Yeah, all right. So some people are saying error, some, and then 00 NA, I heard. Okay, so this is where you need to be careful, and it's good to understand kind of the fundamentals of what's happening. Okay, you don't get an error, you get a warning. So an error in R and a warning in R are two different things, okay? So an error means that I can't actually run it. It's just going to say, I can't do this. A warning means, okay, I did it, but it might not be the answer that you're expecting, okay? So we got 002. Does anyone want to guess how that happens? Yes.
So you recycled the first part of x2.
Yes, that's right. So what does that mean? Okay, so 002, first entry of x3 minus first entry of x2. So that's 0. Second one, 2 minus 2, 0. Last entry, 3 minus, oh no, there's nothing here, right? And so it goes back to the beginning. So it goes 002. Okay. So this is kind of an example of just, it's a simple operation. It may not necessarily be something that you'd even ever run into, but it's important to have an understanding of what's going on sort of underneath the hood so that, you know, in other instances where you're receiving warning messages, you know, it's not a total black box. You can kind of understand what's happening. And it's important to know these things a little bit more fundamentally because you could be running into sort of adverse outcomes that you might not expect, which might not even, or you might not even get a warning message, okay? Okay, so x2 minus x3. So what do you guys think will happen here?
Same thing, so minus 2.
Yep. So it'll be 0, 0, minus 2. The warning message usually tries to tell you what's going on. Sometimes the messages are decipherable, sometimes they're like totally incomprehensible. In this case, you can probably figure it out, right? So the longer object length is not a multiple of the shorter object length. Which actually is something to think about here, right? So if I do like C12 minus C1, 2, 3, 4, here you won't get a warning message because the object length is a multiple of the other length, but this may or may not be the behavior that you intended. Okay. Okay, so we can do addition and subtraction of vectors. We can multiply vectors together, and you could run into the same sort of thing, right? So we know now why if I multiply longer vectors versus shorter vectors, you still get an answer. It's the same type of thing. You would have, you can do the same thing with division. And I can even multiply by a scalar, right? And so x3 times 4, that just multiplies each value in the object by 4. Okay. I doubt that you would run into this. But if you wanted to do matrix operations, right, when you do dot products or cross products, you can actually do that. The way we do this in R is, I believe this is the cross product or dot product. I don't remember. That's the cross product, right? Okay, so x1 percent times percent will give you the matrix multiplication version. So, and I can transpose a vector as well. And that will explicitly make clear that you are operating in rows and columns as opposed to a one-dimensional vector once you're starting to transpose things. So this, we're going to talk more about this with indices, but just to get started, this is probably one of the most common areas to make mistakes is when you're doing index references. It goes row, comma, column. Okay, so it's always RC cola, remember that. Yeah, and we'll talk a little bit more about how that works in just a second, but just remember, row, column. Okay. Any questions about any of this so far? Okay.
I just have a quick question.
Yep.
Is it like specifically a bad idea to try to follow along in Python?
I think that for folks who are going to be working in Python, I kind of assume that your base level of knowledge is like well beyond anything that I'm showing here. So you can chill for today. You don't even have to show up for the Wednesday lecture if you don't want to. I won't be offended or anything because I know that folks are coming in here with a pretty broad set of backgrounds. And so if this stuff is like very comfortable for you right now, very easy, I'm not offended if you want to take off and take off the afternoon. I go through things in a pretty sort of fundamental way, and so there might be some things that you learn. I don't necessarily think it would be helpful if you know Python to try and like be doing 1 + 2 in Python. So.
It's at least handy to know how to translate what works in R and what needs a couple extra steps in Python.
Yeah. So one other thing is that if you're kind of on the fence, you know Python and you don't know R, and you're like on the fence of like, oh, do I want to do the homeworks that might be a little bit harder to do in Python because I don't have the right tools and packages. What I will say is that from a pretty functional perspective, R and Python are very similar. You have to learn a little bit of syntactical differences. And so, yeah, like if you are comfortable with Python and you're jumping into R, it's actually going to be a lot easier for you to do that than for folks who are kind of learning from the ground up. And so, yeah, you can think about that as well if you're interested in learning R. You know, this is probably a good time to do it. Yeah. Okay, so we talked about functions, right? Function name, inputs, and then you get an output. And so there are a bunch of, let's say, helpful functions, easy functions that I'm going to go through right now. This is kind of like my starter list of functions that you'll most likely use at some point. And starting with the help function. So the help function is a function that if you put in the name of a different function, it will basically explain how that works. And so we've actually looked at two functions so far, the concatenate function and actually the transpose function, the T. And so if I were to do help C here, then it should return information about the concatenate function. The combine function, sorry, not concatenate. I should change that. I forget to update that every year. Okay, combine, it's the same thing, concatenate. So generic function which combines arguments. So see here, the help function is pretty standardized in R. It'll tell you basically usage, arguments, details, and examples at the end, which tend to be pretty helpful. Yeah, so there are actually there's a couple other arguments you can put in the function. I'm not going to go through these ones. I don't think they're really useful for a lot of the use cases that you'll find using the combine function. Output type is determined from the highest level of components in the hierarchy. We're going to talk about data types and what these mean later on, either at the end of the day or tomorrow, or not tomorrow, on Wednesday. Yeah, and so they have references and all this stuff and examples that you can look up. Okay, and so we'll go through some more stuff with combine in a little bit. All right, 1 second. Yeah. Okay. The next function that is going to be helpful is called ls. So if you just execute ls as is, it's called the list function or listing function. This will tell you all of the objects that you have currently stored in your environment and the names of all of those objects, right? And so those are all the things that you would see stored up there. But if you need to check, you could be working in an environment with a very large number of variables, and it's easy to check with the ls. Yeah.
Yeah, for like the transpose above, like not transpose, but like the matrix multiplication.
Yes.
If we do like x2 multiplied by x3 and then returns the error saying non-conformable arguments.
Yes. That's because, right, with matrix multiplication, the dimensions of the vectors or matrices that you are multiplying together have to be done correctly. Otherwise, it'll be an error. Right? Yeah. So, if you're familiar with linear algebra, that concept should be apparent to you. It's unlikely that you will be using matrix multiplication and matrix operations, at least in this class. Okay. Next up, we have Rm. So this is called the remove function. So if I put an object in here, Rmx, that removes the object from your environment. And so if you look up in the top right, x is no longer there, And if I type ls, x is no longer in there. Oh, I should mention R is case sensitive, and so x1 works here, it's defined, but capital X1 would not be. Okay. Okay, mean. Anyone have an idea of what this function would do? Okay, average, yeah. So,
Question.
yes.
Is there like a list of glossary of all of like the key functions that we would be using to input? So like all these terms are like brand new to me. I haven't taken any art class.
Yep, uh-huh.
So is there like a glossary of like terms that we can?
I don't know necessarily of, I mean,
like
they,
a cheat sheet of like,
yeah.
okay, what does LS?
Yeah. So actually, let me show you. So after class, and this will be for every lecture, not just for this one. I've sort of painstakingly over the years put together notes that you guys can look at, and so these are all the things that I've done that I'll be sort of talking about, and yeah, and so here, right here, this is the list of, yeah.
Okay.
So maybe that'll be somewhat helpful.
Yeah.
Yeah, there probably will be things that you'll need to learn that's going to be outside the scope of the notes, but you can always ask for guidance. Yeah, and so I'll have definitions and everything for all of these things. Okay, so if I do the mean of 1, 2, 3, what do you guys think is going to get returned? So I heard 2, and I also heard it's not going to work. So enter 1. Did anyone expect that? So it's actually not an error, and in fact, we didn't even get a warning. So what the heck happened? Why is the mean of 1, 2, 3 equal to 1? So what happens if I do the mean of x3? What's x3? 1, 2, 3. So what do you guys think is going to happen? 2. Ah. What the heck? Why did this happen? Remember, functions will take in inputs in certain ways, right? And so actually the mean function expects a single object. And so it looked at this first one and it was like, okay, you want me to take the average of 1. And so the average of 1 is 1. Okay, and so that returns 1. And this stuff doesn't really mean anything. In fact, you could be messing with like, sometimes if it's asking for other inputs, like here, sometimes you may actually be filling in values for other inputs that it's asking for. So when you use the mean function, you have to put in a single object that contains the vector of values that you want to take the mean of. Does that make sense? Right, and so this 1, 2, 3 is not a single object. It's not a vector of numbers, it is 3 separate objects. So in order to do what we want it to do, we would have to do this, designating the input as the object of 3 combined numbers. Okay. Any questions or confusions about that? Okay. Yes.
The help, I think we can also use the question mark and the function to get the help file.
You can do question mark and then the thing, right? Is that what you're saying? Yeah, that's right. So, yes. So this is also will do the same thing as help. Yep. And so we can see.
I think you do it without the parentheses.
Oh, without. Oh, yeah, that's right. I was like, what the? I guess parentheses is kind of a function.
Parentheses
Yeah.
after.
Yeah. There we go. So without the parentheses. Thank you. So here. Okay, great. Let's see. 3. Okay. And let me jump back here. Okay, length. What do you guys think length means?
It counts the amount of numbers in a.
Yep, in a vector. Yes, that's right. And so if I do length of x1, right, x1 is defined as 1 and 2, so the length is 2. Oh, the length, sorry. I will make typos. And the length of x3, there's 3 numbers, right, and so that's 3. There we go. Okay, we haven't been working, so vectors are one-dimensional, and we haven't been working with data frames, which is, or matrices, which are 2 dimensions. But when we get there, we can use these arguments nRow and ncol, which is the number of rows and number of columns. It's basically the same thing as length, but you're looking in a direction on your object. So we'll get to that later. Max and min. So those will return the maximum value in a vector object, and min will return the minimum value in a vector object. Pretty straightforward. Sample is a pretty useful one. And actually, let's see, in RStudio, one of the nice things about the interface is that as you fill out functions, it'll tell you a little bit of information about what the input should be for that function. So the function sample is a pretty useful function that lets you sample from an object n number of times. And so the object that you want to sample from is x, and then the number of times that you sample from it is n. And I'll talk about what replace means in just a second, but essentially, let's say I want to sample from 1 through 50, and so I'll just quickly note 1:50 is a shortcut for combine, where it goes 1, 2, 3, 4, 5, 6, all the way up to 50, right? So it's a shortcut of combining numbers into a vector where your increments are just by 1. And so this will, I now have let's say, a bucket with 50 numbers in it, and I want to draw from that bucket 5 times randomly. And so you can use this function, sample, to do that. So 1 through 50, 5, and I will get these 5 random numbers from that bucket. Okay? So let's do that again. So now I'm going to draw 20 numbers from this bucket. Okay, and so here are 20 numbers drawn from my random bucket that contains the numbers 1 through 50. Does anyone notice anything interesting about this vector of numbers? And oh, I'll also note this one thing that we were talking about before. You'll see there's a 15 here because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's telling you in the next row, we're starting with the 15th index of that object. Anything interesting about this? Yeah.
Looks like it's uniform.
Well, yeah, I mean, I guess you would expect it to be uniform. Yeah, because it's just like,
All the numbers are unique.
yes, all the numbers are unique. So what is that telling us? So what happens if I do 50? All the numbers are unique. So what happens if I do 51? So error, you can't do that. You're not allowed to take out more numbers than there are numbers in the bucket. Unless you replace the numbers. And so that's what this replace is here. So if I do this replace equals true, then voila, it works. And now I can pull numbers out of the hat, and I guarantee that at least one number will be repeated, right? Because it's 1 through 50, but more likely multiple numbers, right? So 46, yeah, 40, yeah, you'll see them all over the place. 48, 48, 48, okay. Okay, so sampling with and without replacement. And notice that when we didn't have anything here, the replace defaulted to false, okay? And you can see what those options are, what the default options are in the help thing. So if I do help sample, you'll see here x size replace. So replace equals false, okay? The last one, okay, this actually can be useful. The probability, so it's the last input is probabilities. Those are meant to weight your sample, and so you can choose to have it much more likely to pick certain numbers, right? So let's say I wanted to do this. So 1 to 50, we're going to draw from it 50 times. We're going to say replace is equal to true. And then I'm going to do, okay, don't worry about what this is. Let's see, no. 0, 49, comma, 1. We're actually going to talk about rep next, but what I'm doing in this probability is 0 49 times and then 1 right at the end. And so now when I sample this, it's all 50s because I've weighted the last value to be 100% of the time, and everything else is 0. So yeah, the last one is just to do weights. Okay, and so that function that I just did is called rep. And so you have x and n here. So let's show you what that does. So it just repeats a value. So let's say I have, I want to repeat the number 1, 10 times, then you can do something like this. Okay? And I can even do that for a vector. So what do you guys think will happen? So I want to repeat 1, 2, 3 10 times. Any guesses? Yeah, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. But some of you are probably thinking, what if I wanted to do 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, right? So you can also do that. You can do rep 1 to 3, each equals 10. And it'll repeat each one 10 times before doing the next index value of the object. And in fact, you could do both if you wanted to, right? And it'll do 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, so on, and then it'll repeat that 10 times. So you can use the each argument to do the kind of within. Okay? Any questions about that? Okay. So we talked about this shortcut, 1 to whatever. It actually doesn't have to be, it doesn't even have to be 1 to whatever. It can be any number to any number. So if I wanted to do 10 to 29, you can do that using this shortcut. This shortcut is a simplified version of the next function that we talk about, which is called sequence, which is kind of the more powerful version of this colon. And it essentially tells you start and an end. And so if I wanted to do this exact same thing, I would do sequence. And actually, let me do sequence 10. So start equals 10, end equals 29, by equals 1. Wait a minute. Oh, from and to, sorry, not start and end. I'm a little rusty. It's been a while. Okay, sequence from equals 10 to equals 29, by equals 1. Okay, and that'll do the same thing. And so the reason why I say sequence is a little bit more powerful is I can do a little bit more customization here. So if I wanted to go in increments of not 1, 0.5, then it'll do that, right? So in the by, I can change that increment level. I can also go backwards, right? Oh, wrong sign. So I can go 29 to 10 in increments of negative 0.5. Okay? Any questions? Okay.
Sorry.
Yes.
Can you go back to the probability thing?
Oh, yes,
in the
sure.
sample?
In the sample, yeah.
I didn't quite get it. How
Okay.
to use it.
Yeah. Okay, I kind of glossed over that pretty quickly, right? So let me show you what I mean. So let me do this. And let's do it like this. So it's actually, we'll do it this so it's a little bit more clear. So I'm gonna say n equals 10, replace equals true. Okay, so here the bucket is smaller, it's just 1 through 5, and I sample from it 10 times. Is it not n? All right. Okay, and so on average, you expect each number to come up twice. You know, there's some variations, so you won't always get exactly that, right? Okay, and so for probabilities, if the chance that I pick a number is exactly the same, then what would the probability be of picking 1? 0.2, right? It's 1/5. And the probability that I would pick 2 is also 0.2, and the next one would be 0.2, and the next one would be 0.2. So this is kind of what's happening behind the scenes. It assumes that each object here can get chosen with the same probability, right? And so here, here, here. Okay, so the same thing's happening. But what if I changed this to 0 and this to 0, and I say added them to 2 and 3? Now I should never pick 4 and 5, and then 1 is half as likely to come up as 2 and 3. Does that make sense? So then I hit enter, and so I'm never getting, I'm never seeing 4 and 5. And here, 1 showed up twice, but 2 showed up 4 times, 3 showed up 3 times. Here, 1 showed up 3 times, 2 showed up 5 times, 3 showed up twice. But the more you do this, the more it'll kind of converge to these probabilities, right? And then if I do, you know, I don't actually think it needs to necessarily add up to 1. It'll kind of do the math for you, I think. Let me see. Yeah, okay. And so if I do this, right, it's basically saying most of this, like a vast majority of the time, you're gonna pick 3, but not always, right? If I sample from this enough, say 1,000, that should do it. Yeah, we see like 2. Is there a 1 in here probably somewhere? Oh, there's a 1. Yeah. Does that answer your question? Yeah, okay, great. Unique is a function that you can pass an object to, and it will tell you the unique values of. And so if I actually just do this last thing that I just did that has a whole bunch of 3s and some 2s and some 1s, and I just say unique, unique here. What do you guys think happens? Yeah, 1, 2, 3, or 3, 1, 2. So it will only return the value sort of non-repeated, right? So it'll give you the unique value. So this is I guarantee you guys will be using unique a lot. It's one of the more useful functions. There's 2 more functions that I'm going to introduce here, but we're not going to talk about. We'll see them in action in just a little bit. Summary and, oh my God, what does STR stand for again? Structure. Summary and structure. We'll see what these do a little bit later on, but I'll just have them here because they're in the notes. You'll be able to refer to them. These are also very handy functions that I presume you guys will probably be using quite a bit in this class. Okay? Okay, any questions about that? Okay. Before I move on, I'm just going to do one thing really quick. Actually, no, I won't do that. We'll just... So these are all functions that are built into R. These are functions that are very, sort of widely used and sort of popular, but you don't have to just rely on the functions that come in R itself. There are packages that have functions in them that we'll actually be using in this class, and you can also build your own functions, right? And so we're going to show you guys how to do that right now. So build custom functions. So the function that we're going to build, we're going to call it I'm the real mean. Okay, because the mean function was taken, so we're going to call it I'm the real mean. And the generic way that this is structured is like so. So this is assigning the name of the function, like this, and then the input over here. Okay, so if I have a vector of numbers, how do I take the mean of that vector? Tell me in English. Yeah.
I add up all the numbers.
Okay. Hey. All right. Step 1: add up all the numbers. We're gonna do that. Okay. So I'm gonna do x sum input. Great. So that's step 1. Add up all the numbers. Step 2. What's the next step? Someone else. Okay. The length of the numbers, right? And so y is the length of my input. Okay, so if I have 1, 2, 3, 4, 5, and there's 5 entries, the length of that is 5. So I'll now have 1 plus 2 plus 3 plus 4 plus 5, and I'll also have the length, which is 5. And then what do? X divided by y, so I'm going to say z is x divided by y. And I'm going to return z. So return ends the function, and it says, spit out whatever this thing is that you put in the return, right? So in function input, the thing that you're working with is the input. That's the thing that gets passed into the function. Then you do all this stuff inside, and it spits out z. Okay? So if I run this guy here, it'll actually just run the whole function, even though if it's multiple lines. And let's test it out. I'm the real mean. 1, 2, 3, 4. What do you guys think gets returned?
1.
Error. Because we pass multiple objects, but it's only expecting one object. Okay? So we need to do 1 to 4, and yay, the average of 1 to 4 is 2.5. Great. Okay. Everyone following along so far? Now I want to jump to our environments. Oh, yes.
Would there be a way to how the new function to be like, either you have one object, and if it's one vector, you just add all the numbers in the vector up and divide it by the length, or you get multiple inputs and then you add all.
Yeah, you could do that. It'll be a little more complicated. You're designing the function to be a little bit more flexible. Yeah, so you could do that. It would be it's actually a little bit complicated to do that. We're not going to get into that, but yes, it's possible. Okay. Okay. So here's something interesting. So we just ran this function. What was our input? 1, 2, 3, 4, right? As an object contains 1, 2, 3, 4. Okay, so x would be what? 1 plus 2 plus 3 plus 4 is 10. I heard someone say that. Y would be what? 4. And z would be 2.5. Okay, so I'm going to go over here where my object is stored. Y is supposed to be 4, and x is supposed to be 10. There's not even an x here. What happened? So we didn't overwrite anything, actually. But what happens in a function stays in a function, okay? It's like Vegas. You're not allowed to pass things from inside the function out to outside the function. Okay. You can. I'm going to show you how. It's like the dark arts, okay? Never ever do it. There's lots of reasons for it. It's very bad practice to do that, but I will show you how to do it in a second. So X, Y, Z are operating in a different environment than the environment we've been working in. And so all this stuff here and in the console, that is known as the global environment, okay? When you're operating within a function, we call that a local environment. And those don't interact with each other except via things that you're passing in the input and technically, I guess, in the output of the function, okay? And so 2 different worlds. That's very standard practice across pretty much most programming languages. Yeah. So don't do this. But if you really have to, you could technically pass things from the local environment into the global environment. And you do that with this second caret, okay? So if I do this and I run this, run the function, and then I run this thing that we ran before, suddenly x is defined as 10. And it shows up there, even though we don't do that. Bad practice. It pollutes the namespace. It's a very easy way of like crossing. You could be like overriding things from inside of your function to things that you didn't anticipate on the outside. Very standard practice to avoid this. I don't know why I show everyone this every year, but don't do it. Okay, so we're going to delete this out of the notes. You won't even see it. Okay. Any questions? Yes.
Why does it say 10 out there?
Yeah, I'm gonna talk about that when we talk about data types later. It's an integer, and that has certain rules associated with it, and we'll get to that. Other questions? Okay.
I have.
Yes.
If that happens, how can I go back to the main hospital?
If what happens?
If I override,
If you accidentally overwrote an object that you had stored previously,
yeah.
you're out of luck. Yeah.
Okay.
Unless you have like a saved, some kind of, if you have that data saved in some different way. But yeah, once you overwrite something, it's gone. It's gone forever. Okay, good question. The next thing that we'll talk about, loops and the apply function. So loops is, I think it can be a little bit confusing if this is the first time that you've seen it. It is a very sort of powerful, sort of standard programming tool. And very useful. I guarantee that everyone will be using this function a lot, you know, in this class and probably anytime you're working on projects where you need to leverage the power of programming. And so a loop is written something like this: for x in 1 to 10, print x. So there are two types of loops. Two generic types of loops: for loops and while loops. We're not going to talk about while loops. The sort of general practice of when to use a while loop is, in the context of a lot of what you guys will be doing, is basically never. Should focus on for loops. And so a for loop, you can think of this kind of in English. So for x in 1 to 10, execute the sort of following commands. And so you can almost think of this as the input into the function, but the input actually is going to change in value multiple times, right? And so if I run this, it's going to print x as x loops through the object vector 1 through 10. So if I run this guy, so you can see the output here that's happening is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Print just says to essentially return the value of the object. Okay. So, any questions about this? Yeah.
Are we going to examine or look at like real life, I don't know, data sets that we could, I don't know, extract and use this
Yes.
to, okay.
Yeah, so right now, this is like introducing the foundation and tools that you need to learn in order to do that.
Okay.
Yeah. And I'll even start to get into some example like data sets in just a second.
Okay.
So let's start putting some of this stuff together in ways that could, feasibly be useful. So this is a very standard example in computer science. So if you've seen this before, don't say anything. We'll see what the class can derive from this. Okay. Let me just copy and paste this actually. I need to do one other thing before this. Yeah, okay, so before I show this function, there's one other thing I want to show. So if function is a way to test conditionals, okay? So what are the conditionals that we could have in here? So if two things are equal to each other, if something is greater than something else, or if something is less than something else, that is conditional. So basically, the way this works is this is a sort of logic gate, essentially, that tells you to do a specific operation if you meet a specific condition. And if you don't meet that specific condition, if you have like an else piece of it following, then you say, then do that other thing instead. Okay? So, what did I do? So if my condition is true, I'm going to do this condition, and if it's false, I'm going to do this condition, right? And so if I run this right now, what will get printed? I'm in the if statement, okay? But if I have something that's false here, then I will skip what's inside of the if statement, and I'm going to go to the else statement. Okay, so here, I'm in the else statement. So normally, you wouldn't have true or false sitting in there. You would actually have something. So does 2 equals 3? Okay, so if you want to ask if two things are the same value, it's 2 equal signs. That's your conditional to test if two things are equivalent. Okay, so is 2 equal to 3? It's false, and therefore what will get printed? I'm in the else statement. Okay? And we see I'm in the else statement. But if I put 2 is equal to 2, then I will execute the if statement, right? And so now I'll be in the if statement. So you can also do other tests, not just if they're equivalent. You can say, are they not equivalent? And the way you do that is an exclamation point followed by an equals. And so that's like replicating the equals with the cross through it, right? And so is 2 not equal to 2? Would that be true or false? False. And so I would be in the else statement. Okay. Is 2 not equal to 3? So that's true, and so we would be inside the if statement. And then, is 2 greater than 3? False, right? And so we're in the else statement, and if I do 2 is less than 3, then that's true, and we'll be in the if statement. Okay? So everyone see how that works? If whatever condition inside of the parentheses is true, we enter into line 71. Otherwise, we skip and go to line 73. Okay? So we're going to combine all of this stuff and build a mystery function. And let me see. Let me just copy and paste it. Okay, so we have a mystery function. This is a good kind of programming practice. When I was a grad student and I was taking some like computer science classes, they would like print out these functions and give them to you, and then you'd have to like figure out what they would do, right? So this is a good kind of practice. So this is a mystery function. We can run this guy, and so I could run it a couple times. Mystery function, let's say 16, and it's false. And if I do, let's say 21, it's false. But if I do, let's say 37, then it's true. Okay, and so the way that you kind of want to kind of figure this out isn't to guess and check a bunch. Is you actually want to kind of walk through the function and see what's happening, okay? And so let's do that together. So I'm going to pass a number into the function. So what's the first number I put in? 16, right? So is 16 less than 2? No, right? And so I'm just going to go ahead and skip this guy, right? Because this condition wasn't fulfilled, and I'm just going to go on to the next one. Okay, and now we say for n in 2 through x minus 1, so x is what? 16, so it's the 2 through 15. So now I'm going to execute a loop where n goes from 2 to 15, and I say percent percent x percent n equals 0. Okay, what does percent percent mean? That is called the modulus operator. It just returns what's known as the remainder, right? So if you do division, so really quick, so 5% percent 2. What's 5 divided by 2? What's the remainder? 1. Okay, so right. Or if I do 11% percent 3, 11 divided by 3 is 3, remainder 2, right? And so 2. Okay. So if we go back to here, okay, for n in 2 through this, let me write it on the board. So we're just going to do this loop manually. So n, and then I'm going to do 16 mod n. So this is going to be 2. What is 16 mod? What's 16 mod n? Or mod 2 in this case? It'd be 0. So 0. And let's continue through the loop. So does it equal 0? Okay, then what do? We return false and we end, right? Remember, when we return in a function, that stops everything, and it just gives that answer. And so what does that mean? So if the number is divisible by 2, then the answer is false. Okay, well, let's do 15 instead of 16. Okay, so 15. So 15, and we repeat all of this, right? So 15 is not less than 2, we skip this. So then we're going to go through this for loop again. So n is, okay, so in this case, what's 15 mod 2? 1. Okay, so do we enter this if statement? No. And so there's nothing else inside the for loop, so we just jump to the next number. So 3. 15 mod 3, 0. So we end. That's it. We're done. So return false. Yes?
What's the point of the for loop?
It
seems like you're
let's see.
returning false before it has any chance to really loop.
What happens if we pick a number that never enters the if statement? Then we return true.
That never enters the if statement?
Yes. So let's take a look. Let's pick a different number. Let's pick 7. Okay, so n 7 mod 2 is 7 mod 3 is 7 mod 4 is 7 mod 5, 7 mod 6. Okay. So in this particular example, we never had an instance where we returned false, and so we returned true. And so actually if we do that, mystery function 7, we return true. What does this function do? Have you seen this before? Yeah, okay, prime numbers, okay? So I'm basically saying, am I divisible by any number besides myself? and 1. And if the answer is no, then I'm a prime number. Okay? So this is a very common example in computer science. So this is prime. This function we call is prime. Okay? Is this the best way to figure out if something is a prime number? Why not?
Because I need to put in the,
Um,
I don't have some.
do I need to test 4, 5, and 6 if I've tested 2 and 3? Right, because you're multiplying on both ends, right? So in actuality, you don't need to go from 2 to x minus 1. You can do it faster if you go from what? You can do a different function, which we're going to call is prime better, okay? And this is exactly the same, except instead of going from 2 to n minus 1, we go from 2 to rounded down the input, the square root of the input. So you actually test not half as many numbers, you actually test exponentially fewer numbers, right? Because if I were testing 101, for example, or wait, 101 is that a prime number? 103 I believe is a prime number. Let's say 103 is a prime number, right? In the first function, I would need to test 100 numbers. In the second function, I would only need to test 10 numbers, right? So 10 times as fast, and that number will increase linearly as the number gets bigger in the first example, but it will only increase by root n in the second number. Okay, so you're kind of like, well, who cares, right? So let's do this. This is a way to clock how fast your function runs. Sys.time is a function that tells me what the current time is. I assign that to an object start, and I run the function, and then I see how long it takes by taking a new system time minus my stored time before. Okay? So let's run this function for is prime, not is prime better. So it's a giant prime number. And we're going to see how long it takes. I have to actually define this function since I changed the name. Oops. Sorry. Wrong keyboard shortcut. There, and then I want to run all of this at once. Okay, run. Da-da-da-da-da. It's going 1, 2, 3, 4, 5, 6, all the way up to this in a giant for loop. Okay, so this took 7.98 seconds to figure out that 9999989 is a prime number. Okay, it's a lot faster if it's not a prime number because, you know, like if it's even, it just stops right when you hit 2, right? But for an actual prime number, okay. And is prime better is the version that only goes up to the square root of that number. And so, faster hopefully? Yes, way faster, right? Okay, so this is this is a principle to think about for you guys more generically as it relates to any analysis that you might be doing with data. Yeah, because some of you guys might be working in larger sort of data sets and that sort of thing. So do you always need to like write the most proper code and make it as efficient and run as fast as possible, right? And I would actually say that the answer is no. You know, there are trade-offs in making your code more efficient. It might be more complex. It might actually take you longer to write that code than the time you save in executing it, right? But the idea here is that you want to be aware of those trade-offs. There is a concept called Big O in computer science, which refers to the size and scale of the problem, how that changes as like your input gets larger, right? And so you can see in some cases it's like whatever, we'll just brute force it. It's not worth spending the time to clean it up. But if you're running into issues where the computation time is really onerous, then you might want to think about, instead of brute forcing the solution, are there more sort of elegant ways of doing it? And in this particular case, right, that the scaling of the problem is very, very different between these two, right? So, at the end of the day, 8 seconds isn't that long of a time, but this is literally more than 1,000 times faster. Yeah.
I'm getting a non-numeric argument to binary operator in error. Is that something to do with this something?
Non-numeric to binary operator. That is a common error. I can't remember exactly what's going on. You have it written just like this?
Yeah.
You wouldn't be running into a 30. Did you find it, or?
Not at a glance, no.
My first instinct is that, are you using the x64 version? Are you using 32-bit or 64-bit? Because I actually wonder if this is too big for a 32-bit.
I mean.
That might be. If not, I'm happy to look at it after class.
Okay, sure, thanks.
Yeah. That would be my kind of first hunch, but it might not be that. Okay. So this function is basically telling us whether a number is prime or not, okay? And so what about if I wanted to test a whole bunch of numbers? Well, we could do that, right? We know how to do that. How would I test every number from 1 to 100, whether they are prime or not? In a for loop, great. For n in 1 to 100, I'm going to print the number and then print is prime n. Okay? So I can go ahead and run this.
Add that in there.
Object. What did I do?
Is it function supposed to be this? Is prime valid?
Oh, about it doesn't.
Problem statement.
Is prime should work too. Like I don't care that it takes a little bit longer. Well, okay. Let me see. No, actually, I do want to use the bad one. Error in is prime n, object n is not found. It's literally, oh, I executed it in the wrong place. Oh, sorry, okay. Yeah. Okay. It's going crazy. I'm a little rusty here, guys, sorry. So this will, yeah, all this does is it'll go through all the numbers from 1 to 100, and it's going to print out false or true. So 1 is not prime, 2 is not prime, 3 is prime, 4 is not prime, 5 is prime, so on and so forth, right? Great. And so we have leveraged the power of the for loop, which we just learned about, with this sort of custom function, and now you know, we're getting to let's say semi-useful territory if you wanted to calculate a bunch of prime numbers.
Sorry, is that the big O then? Is
So big O refers to this idea. So so O of n. So size of n, and then time to complete operation. So big O is a concept about efficiency of a particular operation. So is prime, not is prime better, but is prime increases linearly, right? Because I have to test the numbers like 1 to 100. If I have to test 1 to 1,000, that would take 10 times as long. If I have to test 1 to 10,000, that would take 100 times longer. So it increases linearly with the size of my input, essentially. But there are some functions that increase exponentially. Those are really bad. So you know, there are like classes of problems, really famous problems that increase exponentially, and you know, you can get like a famous, you know, you could get a Nobel Prize or a Fields Medal if you manage to solve it in a way that made it not go like this. There are classes of functions and problems that increase differently. So this might be increasing with rate n, increasing with rate n squared. This might be root n, right? And so is prime better is a lot better than linear, because as n gets bigger, it only increases the time to complete that thing by a small amount. So this concept is important if you are running into problems and operations where it takes you a very long time to do. You might want to think about, oh, is it possible for me to like do it more elegantly and do it, you know, in a more efficient way? It's just something to keep in mind as you delve a little bit more into this world, into like data analysis and that sort of thing, where brute forcing may not always be kind of the best solution. And so, kind of speaking in a somewhat related manner, there's overhead related to any function that you're running in R, right? And so those will actually have their own sort of big O associated with them. And so one of the common ones that I would sort of point to that you could be running into is when you run for loops, which actually tend to be, let's say, a little bit less efficient in R. I'm not going to get into the sort of background of why that is, but the way that R executes for loops actually tends to be a little bit more inefficient. And so in this particular case, I kind of anticipate that this could be a problem that you guys commonly run into. And in those cases, there's actually a function that I think is a lot less intuitive than for loops, but that will do a for loop in a more efficient manner. And that is the family of functions called apply. So I'm always kind of hesitant to get into the like weeds of the apply function because it can be a little bit confusing and it mixes a lot of other concepts that we kind of touch on here and there, but some that we don't. And so instead, I'll just kind of show this to you guys that if it's the case that the problem that you're running into is that for loops are taking you a long time, you might want to look into the apply class of functions. And to kind of just demonstrate that, I'm going to show you this. So we just did a for loop to go 1 to 100. What happens if that loop is a lot bigger and you want to test numbers? And so don't worry about exactly what all of this code is doing. Just know that what I'm demonstrating here is that instead of looping from 1 to 100, I'm going to do this loop from 1 to 100,000. Okay, and I'm going to show you the kind of time that it would take to do that in a for loop versus the time that it would take to do that with the apply family of functions. Okay, so just take a look here. Yeah, and this code will be posted and available to everyone. So if you want to investigate this a little bit more detail on your own, feel free to do that. But let's take a look. Okay, for loop. We're gonna twiddle our thumbs for a while. Yeah, it's actually kind of funny because I had a whole spiel that I would give here, but my like back a couple years ago, but computers got way faster, and so my laptop does it pretty fast now. It used to take like 40 seconds. Yeah, and so using the for loop took 4.5 seconds to do. Using the apply function a lot faster. So I'm showing you guys some of these examples. I'm showing this one in particular because I actually think this is a more practical one that you guys could run into dealing with sort of larger for loops. Think about using apply. I actually don't always advocate for everyone to just do apply functions and replace for loops all the time, even if it's less efficient. I actually think that for loops are a little bit cleaner and more intuitive to understand. I think code interpretability is an important skill to have when you're programming, and so I think it's a lot easier for people to digest what a for loop is doing and what it means compared to some of the apply functions. And so if you're like not running into these difficulties where you have to wait 2 seconds instead of like half a second, it's like, okay, that's not a big deal, right? But the difference here could be like, oh, I had to wait 4 hours for my code to run versus 2 minutes for my code to run. Then it's like, okay, do this thing, right? Yeah.
What is D in this example?
D is
You define it
Combine
in 116.
X1
Yeah.
and X2 and then.
yeah. I'm running. I'm running a uniform set of numbers through a for loop. It's just a generic input, basically. Yeah.
Huh. Okay. It kind of looked like you were constructing a really, really, really big array, but I guess.
No, it's not an array because I'm not concatenating like that and filling out. I'm just binding 2 columns together, actually.
Okay.
Yeah. This function isn't even actually the prime thing. This is actually just taking the average of a bunch of numbers in a for loop. So it's taking the average of 2 numbers 100,000 times, and that is a lot faster using the apply because the apply will actually do it in parallel.
So apply will just throw whatever function you want at the problem, but a lot faster than a for loop do it yourself.
Yeah, so essentially this is roughly but not exactly what's happening is in a for loop, I'm doing an operation 100,000 times and it's walking through them one at a time. In the apply, it's doing it in parallel, so it does a bunch of them at the same time. kind of. Yeah, it gets a little bit complicated when you think about what's actually happening, but essentially that's what makes it a lot faster. Okay, so I think we will end here for today. Yeah, the notes are going to get posted shortly after this, and then we're going to just continue on where we left off on Wednesday. Wednesday we'll kind of conclude our tutorial. Yeah. Also, does anyone know what a pirate's favorite programming language is? Aye, but his first love was always the sea. All right. Thank you. Yep. Give me one quick second. How do I? Oh.